In this video, we'll continue exploring ways to describe distributions of quantitative data, focusing on measures of spread. Once again, we were investigating the age at which mothers tend to have their first child. Previously, we looked at the data from 1980 and saw that it had a mean of 22.6 years and a median of 21 years. Instead of looking at 2018, let's take a step back even further in time and look at data from 1950. Like with the 1980 data, this distribution is unimodal and skewed to the right. It also has a mean of 22.6 years and a median of 21 years. So does this mean that mothers were having their first children at the exact same ages in 1950 as they were in 1980? Pause the video and see what you think. Even though these two distributions have the same measures of center, you might have noticed that in 1980, mothers were sometimes having their first children, sometimes in their mid-teens, and sometimes in their mid-30s. And this didn't happen in 1950. So these distributions are definitely different from each other. The key is in the amount of spread, or variation, that there is in each distribution. Measures of spread are meant to summarize the amount of variation in a dataset and, in particular, how far from the center the data values tend to be. These measures include the range, standard deviation, and the interquartile range. Let's look at these measures for the distributions of mothers' ages from 1980 and 1950. First, let's look at the range. The range is the difference between the largest and smallest values. Another way to think of it is it's the width of the data. So, for 1980, the largest value is 42, and the smallest is 14 years, so the range is 28. For 1950, the largest value is 31 years, and the smallest is 18 years, so the range is 13. So, using range as a measure, there was twice as much variation in 1980 as there was in 1950. However, we have to be careful about the range. If there were a few people in 1980 who had their first child at age 50, then the range would increase to 36. So the range is easily affected by outliers. Next, let's look at the standard deviation. The standard deviation is used in conjunction with the mean. One way to think about it is as, more or less, the average distance from the mean to each data point. Let's look at the formula for standard deviation to see what it's actually telling us. The value of each data point is written as an x sub I. For example, here is one mother who had their first child at age 19, so 19 is a value of x sub I. Then we subtract the value of the mean, which is written using the Greek letter mu, to find the distance from the data point to the mean. For example, when we subtract 19 minus 22.6, we get negative 3.6. This negative 3.6 is called the deviation from the mean. Now, we want this distance to be positive, and we do this by squaring the deviation. And then, since we want this to be an average, we'd add up all of these squared deviations, which is represented by this Greek letter capital sigma, and then divide by n, where n is the number of data points. And it turns out that if we're only looking at a sample and not the entire population, we would divide by n minus 1 instead of n. The reason for why we do this is a little complicated, so we'll look at that in another video. Then, since we squared the deviations, we undo the squaring by taking the square root. And all of this is equal to the standard deviation, which we represent using the letter s. So this is the formula for measuring the standard deviation. The standard deviation is used in conjunction with the mean. For 1980, the standard deviation is 4.6 years. This tells us that individual mothers tended to have their first child when they were 22.6 years old, but in the entire sample, mothers tended to be 4.6 years younger or older than the mean when they had their first child. And in 1950, the standard deviation was 2.3 years. This tells us that individual mothers tended to have their first child when they were 22.6 years old, but in the entire sample, mothers tended to be 2.3 years younger or older than the mean when they had their first child. And we should keep in mind that both mean and standard deviation are affected by the distribution having outliers or being skewed, as is the case here. So these might not be the best measures of center and spread. Finally, let's take a look at interquartile range. The interquartile range, or IQR, is used with medians. It is the distance from the first to the third quartile. So let's take a moment to talk about percentiles and quartiles. Here is a made-up set of data, and I have already put the numbers in order. There are 14 numbers in this list. We've already talked about the median, which splits the data into two equal-sized parts. Another name for the median is the 50th percentile, because 50% of the numbers in the dataset are less than the median. Similarly, the 25th percentile is the value that cuts off the lowest 25% of the data. Since 25% is a quarter of the whole, it is also called the first quartile. Another way to think of this is that it's the middle of the lower half. And the 75th percentile is the value that cuts off the lowest 75% of the data. It's the middle of the upper half of the data. Since 75% is 3/4 of the whole, it's also called the third quartile. The interquartile range is the distance from the first to the third quartile, so it's also the width of the middle 50% of the data. So in this example, the IQR is 17. For the mothers in 1980, the first quartile is 18 years and the third quartile is 25 years, so the interquartile range is 7 years. This tells us that individual mothers tended to have their first child when they were 21 years old. But in the entire sample, the middle 50% of the mothers tended to be within a 7-year window around the median when they had their first child. For the mothers in 1950, the first quartile is 19 years and the third quartile is 23 years, so the interquartile range is 4 years. This tells us that individual mothers tended to have their first child when they were 21 years old, but in the entire sample, the middle 50% of the mothers tended to be within a 4-year window around the median. Now, let's summarize what we've seen here. The measures of spread summarize the amount of variation there is in a sample. The range measures the total width of the distribution, but it is affected by outliers. The standard deviation is used with means, and the interquartile range is used with medians. And both of these give you an idea of how far values tend to be from the center of the distribution. Overall, when you describe a distribution, it's important to talk about shape, center, and spread. For example, when we looked at the distributions of mothers' ages when they had their first child in 1980, we saw that it was unimodal and skewed to the right. Unimodal tells us that we can use a single measure of center, but the skew tells us that the median might be a better choice than the mean. And the median of 21 years tells us that half the mothers had their first child when they were 21 years or younger. And the IQR of 7 tells us that the middle 50% of the mothers had their first child when they were within roughly 7 years of the median.